Potentiometer has is a very simple piece of equipment. It has a knob that you can turn, and by turning the knob, you're changing the resistance between the center lead, called the wiper, and one of the other two leads, depending on how you have it attached. So what we're going to do is just verify the performance of a potentiometer, learn a little bit about multimeters along the way. One of the things we're going to need to do is keep track of where we are. So this potentiometer has a knob, and it turns not quite 360 degrees. It also has an arrow on the top of it that you can see. I'm going to put a single dot on the body right here, and that'll help me keep track of position. I'm going to call that position A. Over here on the opposite side, rotating the potentiometer to the other extreme, I'm going to put 2 dots. And that I'm going to call position C. So I have 2 positions on my potentiometer. I'm going to call them position A and position C, because I'm going to refer to these pins, pin A, B, and C. So A, B, and C are the 3 pins. Make a little schematic here of my potentiometer, and I'm going to make the wires appear to stick out the top. In fact, they stick out the bottom, but I'm going to call this single dot and this double dot, I'll call this pin A, the middle wiper pin B, and the third one pin C. Turns out it doesn't matter the direction A or B, so you could have it flipped around, but we just want to keep track of things as we go. Okay, so the first thing I want to do is get a reading of the potentiometer's resistance across A and C. So I've got my trusty multimeter here. I'm going to turn it to resistance. Currently on overload because I have an open circuit, but when I touch my leads together, I get essentially 0 ohms. The first thing is I'm going to measure the resistance across A and C. Now remember, I've got my dots, so it doesn't matter the polarity here. A to C, so the resistance from A to C is 10.09 kiloohms. And that won't change as I turn my knob. I verify that. I'll hold my potentiometer without adjusting where the leads are connected, and I'll turn my potentiometer from one extreme to the other, and although the least significant digit may flicker a little bit, there's no change. The key is to understand how the potentiometer changes when I connect, say, the middle lead and the outer lead. So that's now I'm connected I'm measuring the resistance between A and B, and my potentiometer currently reads 0.05. If I turn it completely the other way, my potentiometer reads 10. So once again, I'm 10 kiloohms, someplace in the middle, about 4 or half, and all the way back to the other extreme is 0. So what I'm going to do is just make a table, and I'm going to write down positions. Now, if I look at my cartoon here, my arrow on the knob can point all the way to the A or turn all the way around and point to C. I'm going to label some points here for reference, and then later we'll be able to graph this. So I'm going to also call this position 0. Straight across, say 90 degrees rotated counterclockwise, I'm going to call that position 1. I'll call straight down position 2, 270 degrees rotated around position 3, and the maximum position, or pointing towards C, is called 4. So I'm going to call these position numbers P, 0, 1, 2, 3, 4. And I want to be able to record the resistance between, in this case, I'm measuring the resistance according to my little convention here. Things are a little snug, but I'm measuring the resistance between pin A and pin B. So this is resistance from A to B. Potentiometer is over now. I've rotated it back to essentially position 0, and I've got 10 kiloohms, 10.08, and I'm going to put a kiloohm on the table title so I don't have to keep writing it down. Rotate approximately. Now this is very approximately position 1, and I get 8.98. The approximation of my angle here doesn't really justify 3 significant digits, but I'll write them down and truncate later. Now position 2, 5.26, position 3, it's jumped to 2000, but the units have changed from kiloohms to ohms, so it's 2.07 kiloohms, and back to position 4, and essentially 0. So what I have here is a device that allows me to produce a variable resistance, and that's essentially what a potentiometer does. Now, for your own homework, I would ask you to graph resistance as a function of position, and I would also ask you to repeat this exercise where now you're going to measure the resistance. I just measured the resistance between A and B. I want you to measure the resistance between B and C. Basically repeat these experiments. Fill in this table. Now to make a graph, what I want you to do is I want to make a graph of the resistance, say A, B, as a function of angle. Okay, these positions are arbitrary, just to be simple, 0, 1, 2, 3, 4. Those aren't angles, and the distance between 0 and 1 is not equal to the distance between 1 and 2 in terms of angle. So if you do a little arithmetic here, or actually a little trigonometry, I'm going to write over here the angle alpha, and you can figure that out, or you can figure alpha divided by alpha max, where alpha max is the maximum angle of, say, 360 or 2 pi radians. If you follow along, position P would be alpha max 0. This would be 0.167. This would be 0.50. 0.3 would be position 3 would be 0.83, and position 4 would be 1.0. So what I'm essentially doing here, I'll draw this again. If my angle, if this is 0, and this is alpha max, I'm going to move 0 over to here on my alpha scale. Alpha equals 0, not 0 angle. And I need to change this. So if this is really 45 degrees and this is really 315 degrees, I can rescale this and get a scale 0 to 1. So do that, plot resistance versus alpha on alpha max, repeat the measurements of RBC and make a different plot, or you can add it to the same graph and just label the curve differently. So what we're going to see in this case is that there's a decrease of resistance with position. So to recap, we have a device called a potentiometer. The pins have been a little mangled by my measurements here, but it has 3 pins. Those 3 pins basically give us a voltage divider, and by changing the angle from 1 dot to 2 dots, or from A to C, by changing the position of this knob, we get a different resistance. The resistance that we're talking about is between one of the edge pins, either A or C, and the middle pin, which is called the wiper.